Okay, so far we've done lots of inequalities, but we've left out one other type, which is pretty important. Okay, so that's going to be, well, that's actually the name of the section. Other types of inequalities. We already did. In the packet. 2.3 was just an inequality review section, so I don't... Okay. Here's what I consider regular inequalities. Okay? Regular inequalities would be any of the ones that you've already seen before. So something like 3x plus 7 less than 2x minus 4. This is a regular inequality, and no one should have any problem solving it. Okay? Another regular inequality would be something like absolute value of 2x plus 5 greater or equal to, let's say, 10. It's regular because you guys have seen these before. How would you solve this one, by the way? Ellie?
Well, you have to set up two equations. One is 2x plus 5 greater than or equal to 10.
Yep.
And then the other one is 2x plus 5, and flip the sign, minus 10.
Very good. Okay. And it's an or statement. Okay. So we have regular inequalities that are just without absolute value. We have inequalities that contain absolute value, but you guys know how to do those. Okay. So this is what I call regular. Okay. The other types of inequalities that are in this section, I'm going to call non-linear. What do you think of when you hear the word linear?
Line.
Okay, so non-linear would be
Not a line.
anything that's not a line. Parabolas, right? Cubic equations, squigglies, yep. Anything that's not a line. And that's the kind of inequalities we're going to talk about now. So, let's start with an example. Let's say we have x squared plus 5x minus 6 is greater than or equal to 0. Okay? I'm going to show you two approaches to solving things that are inequalities that are not linear. One will be graphically, which we'll do first because it's pretty easy to see visually what we're talking about. And then I'll show you the shortcut. Everybody likes shortcuts, right? Yeah. So well, let's not do that because you need to understand where the shortcut's coming from. All right, so here's how I'm going to approach this. This is an inequality that we really haven't seen before, right? We've never seen inequalities with quadratics in it. So I'm going to use my calculator to kind of give us an idea of what's going on. So let's put x squared plus 5x minus 6 into the calculator. And let's hit graph. And I'm not sure why there's this little bump over here. Let me get rid of that. I don't know. Huh. That's very interesting. I'm not sure whose calculator. Oh, yeah. What is that? Is that always there?
Were you playing with the draw?
Okay.
You should go clear draw. I don't know.
Clear draw? How do I do that?
Second program.
Second program. Ah.
Did it.
Okay, thank you.
What is that?
I don't know.
That's the Levitas.
All right, so here's what I'm going to do. I'm going to sketch my picture here. What do the x-intercepts look like here?
Probably like
1, negative 6. So I'm going to put those there. And then we have, parabola. So something like that. Okay, so that's the picture that we're looking at. I'm going to put the calculator away for a second. And now let's think about what this means. So equation, x squared plus 5x minus 6, is represented by what? By this parabola. So this whole parabola represents x squared plus 5x minus 6. Okay? What we're saying here is that we want the parabola to be what? What does this mean? Greater than or equal to 0. Well, looking at the picture here, if let's say I'm right here on the parabola, would we say that this is negative or positive? Negative. What about over here? What about down here? What about here? Okay. Do you guys see where I'm going to here? If I color or shade, not that you need to do this, but just so it helps explain what the answers are, the part of the parabola that's greater than or equal to 0, it would be these two parts here. Does everybody see that? Everybody good with that? Okay. This part of the parabola that's underneath the x-axis is smaller than 0, so we're not going to include it in our answer. So as far as solving this inequality, we could say that the solution is, if I go from left to right, what's the smallest number this way that will be good? Negative infinity. Good. And then if I go to the right, where do I stop? We stop at negative 6. Do I want it to equal 0 or no? Yes. So this is a bracket. Anytime we have more than one set, we use union. And then I pick right back up at 1. And I keep going all the way to infinity. So this is the solution for this inequality.
Why is there a bracket on negative 6?
Because negative 6 gives us 0, and we want it to equal 0, because it's a greater or equal to problem. We will.
It's a shortcut.
Okay. Are there any questions on visually what just happened here?
Is a shortcut factoring it?
Yes, factoring and key numbers is a shortcut. Okay.
Oh, that's crazy.
Let's try one more with a graph. And I'll go back to this first example, because it's a good one to do with our shortcut. Let's say we have x plus 5 over x minus 1 less than 0. This is not linear. It's not like the other inequalities that we've been solving. And again, I'm going to approach this like I don't know what to do, so I'm going to see if the calculator will kind of shed some light on what part of the graph I need. So I go back to my graphing menu, and I'm going to type in x plus 5, put parentheses around the numerator and denominator so that you guys get the correct graph. Hit graph. Okay. So we have asymptotes. And now, if I'm looking at the graph, looks like there's a vertical asymptote right here at about x equals 1.
Wouldn't it be a 2?
What's that?
Wouldn't it be a 2?
I don't think so.
Are you like looking at where the line comes straight on the graph?
Yes.
Yeah.
In fact, if you look at the table, there is a value at 2. Here's another way to find the asymptote on your graphing calculator. Right where the error is, that's where the asymptote's going to be. Okay. Now, the rest of the graph looks something like this. Looks like there's an x-intercept. It's kind of hard to see on the screen here, but it looks like there's an x-intercept right here, and then it actually looks like the graph goes above the x-axis. Do you guys see that? So here's an x-intercept. It goes a little bit above there, and then it comes down and it goes and does something like that. Okay, so where is my graph smaller than 0? That's what this means, right? Well, what do you suppose this point's going to be right here?
0.
Well, that's what the function equals. What's the x value there, though? X equals -5. Okay. So would we agree that this part of the graph is the part that's smaller than 0?
Yes.
Everything to the left of this point is no good because it's above the x-axis. And then everything to the right of this asymptote, which was x equals 1, is no good either. So let's see if we can write our solution. How many sets of numbers work here? How many sets?
2.
Well, we had
1.
2 sets here, right? 2 different sets. How many sets work here?
1.
Just 1. Let's write it down. So the solution starts at -5. Now, do we want it to equal 0? So I'm going to put a parentheses. And then it's going to end, or at least get really, really close to what?
1.
1. So there's our solution. Okay? Do you guys understand how these work, kind of looking at graphs?
Yeah.
Less than 0, greater than 0. Find the parts of the graph that work. That's what you write down. Yes?
So it kind of does that thing where next to the 1, where it just keeps going right next to the 1.
Yes.
Forever.
Yes. Yes. Exactly. There's actually a horizontal. We're going to talk more about this in 2 units. There's a horizontal asymptote at y equals 1. So both of these graphs will get really close to 1 from both sides. Okay? All right. This is the graphing method.
Wait, what did you do about the other thing?
What other thing? There's only one part of the graph that works right here.
You want me to look
What is
for
the other one?
Well, this says smaller than 0, right?
There's no solution.
So this is the only part that's smaller than 0 right here.
So it's the other one, no solution.
Well, no, it just doesn't work for this because this is positive. We want this to be smaller than 0.
No solution.
It's not no solution. The solution is right here. We wrote it down.
No, for like the x plus 5.
I'm not sure what you're asking. Okay. Here's the shortcut. One, factor after the inequality is set to 0. So if you notice, both the examples we did, it was less than 0, greater than 0, one or the other. Okay? 2, find key numbers. This is a new vocabulary word. Key numbers are numbers that come from x-intercepts or zeros, same thing. Or vertical asymptotes. Okay, so any x-intercepts or zeros that we know of or vertical asymptotes that we see, those are our key numbers. Okay? 3. Plot key numbers on a number line. And then 4. Test all the intervals to find correct solution. Looks like there's a lot of steps, but it'll be really quick. Okay, so what I'm going to do,
Do the shortcut for each of them.
I'm going to do the shortcut for the first example, so you guys kind of see how it works. Okay, I'll wait a little bit here. Oh, here's your calculator back. Thanks.
Test all the what?
Intervals. Sorry, my R.
What is KVM?
What is what?
You have such curvy handwriting.
KBM?
Yeah, like a lot KBM.
Key numbers.
What?
Sometimes if you hear as I'm writing, usually you can decipher my handwriting. Sorry about that. Okay. So the first example again was,
X squared plus 5x minus 6
thanks, CJ.
greater than 0.
Greater or equal? Okay. All right, so we know that we can graph this. And sometimes that's not a bad way to do it. But you know what? Factoring and key numbers is pretty quick too. So, and a lot of times, if they get more complicated, especially if the graphs are really involved, this is actually easier. Because imagine if you had like 4 or 5 different pieces of the graph that you need to find and locate. That could take a while. Okay, so how do we factor this? So x minus 1, x plus 6. Okay, so that's the first step. I factored it. 2, find the key numbers. Well, I'm just going to write them down. The key numbers are the x-intercepts are 0. So what do I do with these factors here? Set them equal to 0. So x is 1 and? So here are the key numbers. Everybody good so far? Now I'm going to put those numbers on my number line. So negative 6, 1, and 4, test all the intervals. So how many separate pieces of the number line do you see here? So that means that we have 3 intervals that we need to test. Okay? Here's how we test it. So pick a test number that's to the left of negative 6. Sure. So I'm going to use negative 7. Okay, now here's the nice part about this. What does it mean if we want this answer to be greater or equal to 0?
It's going to be positive.
Positive, right? Does everybody understand? If it's positive, it's good, right? So here's the easy way to do it. If you plug negative 7 into the first factor here, what's negative 7 minus 1? A negative or a positive? It's negative. So I don't even care if it's negative 8 or negative 4 or negative 1/2. I just care that it's negative.
Wait, why do you? It's minus. So you put in the negative 7 for x.
Yep. And now I do the same with here. Negative 7 plus 6 is going to be a negative again. So overall, my final answer is positive, because a negative times a negative is positive. Does everybody understand that? Okay. Now we repeat, go to the next interval. From negative 6 to 1, what's a really nice number to check? Good. If I plug 0 into the 2 factors here, 0 minus 1 is negative. 0 plus 6, positive. And a negative times a positive is negative. Okay, and now we go on to the next interval. Pick a number that's to the right of 1. Okay, 2 works. So I checked negative 7, I checked 0, and now I'm checking 2. If I plug 2 into both of these, we get a what times a what? Positive times a positive. Positive times positive is positive.
So when you're doing the first little section of the line, you're looking for a point that's to the left.
Yes, you want to pick numbers that are not exactly these. So pick a number over here, pick a number in here, and then pick a number in here.
Oh.
Okay, so now what does this help us with? Well, we want it to be greater or equal to 0, right? Well, which of these 3 are greater or equal to 0? The first and the last. So this is going to work. The middle one is not going to work. And the one on the outside is going to work. And now all we do, okay, if you look at the fact that we want this to equal 0 means that we're going to include our boundary points, -6 and 1. Those key numbers get included here because we did want to equal 0. So if I actually look at the graph, here's what I'm looking at, and then now we can write the solution. So what is the final solution going to look like? To bracket. Good. Which is the same exact thing that we kind of deciphered from our graph. Does everybody see that? Okay. We're going to do one more example. Patrick's going to walk us through it. Oh, you know it. X to the 4 minus 7x cubed greater than 30x squared.
Oh, you move the 30x squared over and it's greater than 0?
Yeah, I think that's about right.
Watch me get this, Mr. G.
I believe you can do it.
And then you factor out x squared.
Okay. You guys agree with him?
Yes.
Okay. Factor out x squared, so what's left?
X squared minus 7x minus 30. Minus 30. It's greater than 0.
So now we want to find our key numbers, right? So how do I find those key numbers?
Three factors. 3 and 7.
The factors?
Yeah.
Okay. So I can we should probably keep factoring. Okay. So what is it?
X minus 10.
Yep.
X plus 3.
Okay.
And x equals 0, 10, and
0, 10, and -3. So we have,
Why 0, 0?
because we have x squared outside, if you set that equal to 0, x squared equals 0 gives you x equals 0. Right? X squared equals 0, square root both sides, square root of, I don't know what that is. The square, sorry, the square root of 0 is 0, right? Okay. So now that we have our key numbers, Patrick, what's next? Of course I know. I don't know if you know. What do I do with these key numbers?
All those are x-intercepts,
Yep.
so we use those to,
Where do I put them?
you know. Isn't it negative infinity to...
Oh, whoa. You're getting ahead of yourself. Let's put them on a number line first.
That's too much fun.
Put them in order. -3, 0, 10. And now how many intervals do I need to check here? We have 4 to check. So let's pick some test numbers. I'll test. Okay, -5. What about here?
-2.
Sure. What about in here?
0.
0 is a key number. I cannot use 0. 5 sounds good. You go ahead and do 0.2, Saeed. We're gonna do 5 because it's a little easier.
Why are we doing -5?
And then 12. Okay, 12 is good. All right. Does everybody understand where these? They're not random. These 4 values are numbers that are in between these key numbers. Yes. Okay. And now we're going to plug in each of these into the original inequality and just keep track of whether we get a positive or a negative. All right, so let's. When I plug -5 into x, and I'm by the way, I'm looking at this one right now because it's easier. Just check here.
Use x squared.
-5 squared becomes
25.
so positive. If I plug -5 into x minus 10, this factor becomes negative. If I plug -5 into x plus 3, that becomes negative. So overall, this value is positive. The 2 negatives give you a positive. Positive times positive is positive. Right? All right. What's up? Where?
Oh, no.
Okay.
No,
Negative 2, if I plug it into x squared, becomes,
Or
so positive. Negative 2 minus 10, negative. Negative 2 plus 3 is positive. 2 positives times a negative number is negative. And I'm going to fill in all my answers here in a minute. I'm going to check 5 now. So 5 squared is positive. 5 minus 10, negative. 5 plus 3, positive. I get a negative again. Last interval. Checking 12 now. 12 squared, positive. 12 minus 10, positive. 12 plus 3, positive. So overall, who's saying negative?
Back to 1.
All right, so let's go back to my inequality. We wanted this inequality to be greater than 0. So my answers are only where I have positive. So right here, these do not work. And now, do I have open or closed circles here? Why open? Not greater or equal to. Very good. So what is the final solution?
How do you know?
Negative infinity with a parentheses, right? Okay. Union. Okay. There it is.
Told you, Mr. Jack.
Yes, sir.
that negative 3.
What negative? This one?
You said it's because it's the void.
It's from the number line.
Oh, I thought it was a negative.
Oh. It's not that illegible, is it?
No, it's just Elliot.
No, you wrote negative 5 for the.
Yeah, because we're testing it. We're checking that. Yeah, you want to check on the outside. All right, that's good for today. You guys get into your group.